Simulate fault injection on a function using TrueCode. TrueCode embeds a powerful tool to discover potential flaws in your code that might lead to undesired behavior of your software, the Fault Injection Simulator. Using a RISC-V-based emulator, TrueCode will simulate lasers shooting at random places on a chip running the function under analysis. This is helpful to discover how random changes on the data can lead to undesired execution flows and, finally, to security flaws. To help with the analysis, TrueCode will generate harness code, namely function stubs, to isolate the function under analysis, and correctly initialize and finalize the state of the execution for the simulator. The simulation will create execution traces, which help you reveal the weak points of the function. This tutorial assumes that you have already created a workspace in TrueCode, that you have correctly created a compilation database, and that you have indexed your codebase for function definitions. These previous steps are required before proceeding with FI simulation. If you would like to know more about how to do these previous steps, please refer to the respective tutorials. Stage 1. Select a function for fault injection simulator. To start the process of fault injection simulation, go to the Analysis menu, then select Dynamic Analysis FI Simulation. This will open the Dynamic Analysis FI Simulation tab, starting at the Select stage. This tutorial does not cover the first part, Library. Please refer to the TrueCode's documentation to know more about this stage. On the second stage, select You can show a list of all the function definitions present in your index. Browse this list to find the function you would like to simulate, or right-click on the titles of the columns to use them as filters to find easily the function you want. Once you have found the function, select it, and right-click on it to reveal the function harnessing options. On the Context menu, select Create Dynamic Test Case to start the harnessing process for fault injection. If you selected a function that you have already simulated or even only stubbed, shown on green color on the list, TrueCode will ask for your confirmation for overriding the already present function harnesses. Stage 2. Configure fault injection simulation. In the Settings stage of the wizard, you can change the configurations of the analysis. Call depth for function stubbing. When creating function stubs, TrueCode will start analyzing from the selected function and discover the functions called up to the configured depth. The definitions for the called functions will be searched on the codebase index, and their bodies will be inserted in the file for compilation to the target architecture. Number of fault injection asserts. TrueCode must know the locations in the code that will be considered as fault targets. Once the execution reaches one of these source locations, the fault is considered successful. In TrueCode, you can configure up to 8 asserts in the selected function. Configure fault targets. Once TrueCode reaches a point in the code that has been marked as a fault target, TrueCode needs to know what to do with the execution trace that has been followed up to that point. By clicking on this button, for each configured fault target you can select to either collect the trace, collect optionally, or drop the trace. Max clock cycles. Each execution of the function under test will run a maximum number of processor cycles. You can choose how many cycles will TrueCode execute per run of the simulator. Stop criterion. The simulation can potentially run for a long time. To lift this restriction, you can set a stop criterion. Once it is reached, TrueCode will no longer execute more instances of the simulation, and you can start analyzing the results. If you would like to configure these stop criteria, you can go to the Workspace Settings menu and then to Dynamic Analysis Settings. The upper part of this window shows the values for each of the stop criteria for simulation. Please note that the list of configurations presented in this tutorial is not exhaustive. You can discover more options when you click on the Show Optional Fields option. Please refer to TrueCode's manual to know more about these options. Once you've finished configuring the simulation, click on the Next button to move to the next stage. Stage 3. Configure and review automatic code harnesses. After you've finalized configuring the simulation, TrueCode will use the Codebase Index to find the function definitions, macros, and global declarations needed to assemble the executable. TrueCode will present the result of this process in the stub tree. In this stage, you can review all the code collected and put together by TrueCode. Nodes in red mark stub nodes, function definitions, declarations, among others, that need to be resolved before continuing. Nodes in yellow are configurations that require your confirmation. At this stage, you may want to check and correctly initialize the state of the execution, such as variables or structs. Now you must select one or more fault targets in the generated source code. Remember that a fault target is a path in the source code that is not meant to be reached, but can possibly be reached by flipping a bit in memory or skipping an instruction due to fault injection. Once you have reviewed the stubs and set up your fault targets, you can click on Next to move to the next stage. Stage 4. Review harnessed code. On the next stage, TrueCode will present you the harnessed code generated for the simulation. Please note that TrueCode will organize the generated code in a dynamic analysis folder. Moreover, TrueCode will create a new source files, organizing the stubbed code in the same manner as it originally is in your codebase. You can browse all the generated source codes by clicking on the drop-down list on the top of the tab. For each one of the generated files, you not only can review the code but also make some modifications if needed. Please do not forget to save any modifications on the generated files by clicking on the Save button. Once you have reviewed the harnessed code, you can move to the next stage by clicking on the Next button. If you have already executed some other FI simulations, you will be prompted to overwrite the main.data simulator file. Click on Yes to overwrite the file and proceed to execute the new stubs. Stage 5. Compile and execute the fault injection simulation. Before this stage starts, TrueCode will use the generated stubbed code to compile and link an FI executable suitable for running on the RISC-V architecture. After this, TrueCode will load the compiled binary in the simulator and start simulating the execution of the instructions in the binary. The simulator will inject faults while executing instructions from the loaded binary. In the simulation phase, you can see three main panels. On the left, you can see a list of the collected traces that reached the fault target. Note that the very first collected trace corresponds to the expected trace, which is used as a reference to compute the deviations against which the fault cycles are compared to. In the middle, you can see the particular selected trace, indicating in black the initial part of the expected trace, on blue the fault injection cycle, and on red the deviation of the trace that led to a fault target. Note that this is not an assembly language of the target architecture, but rather a high-level overview of what the simulator has executed. On the right, you can see how the instructions of the selected trace are mapped to the stubbed code. If you select an instruction on the center panel, TrueCode will highlight on yellow the corresponding source line on the right side. Additionally, this panel also shows histograms about the rate of successful fault injection cycles. When selecting multiple traces, the blue histogram bars will show a percentage about how many fault injection cycles inserted on that particular line led to the execution reaching one of the fault targets. Finally, on the bottom right corner of the window, TrueCode offers statistics about the execution of the simulation. This particular value shows how many simulations reached the fault target, named number of faults, and how many simulations have been executed by TrueCode, named number of simulations. TrueCode also computes the ratio between these two values and displays it as a percentage. For fault injection simulation, TrueCode is capable of suspending the simulation and resuming it later. To do so, you can click on the pause button. To resume it, you can click on the pause button again. If you would like to stop completely the simulation, click on the stop button. Depending on the status of the execution, this panel also shows information about the status of the simulation, paused, running, or stopped. Once you have collected the results you need, you can click on the next button to move to the next stage. Stage 6. Analyze the assembly. In the last stage of the simulation, TrueCode will display a disassembly of the executed binary. In some cases, different processor instructions can map to the same source code line. To ease discovering what does the processor executes when analyzing a trace, you can match the hexadecimal address of the instructions against the disassembled binary object for a better granularity of the analysis. This completes the tutorial for fault injection simulation on TrueCode. If you would like to know more about this feature, please refer to the TrueCode's documentation. Thanks for watching.